Okay, so let's get started. 15.1, this is the title. And of course, this is your essential question. How can you solve equations involving variable exponents, right? Okay, let's keep going. So today is a really exciting lesson. We're gonna go straight to the question, okay? It's basically something like this. Let's do a your turn question right away. Okay, I'm gonna make this screen a little bit bigger. There you go. It says solve by equating exponents and using the equality of basis property. Oh yes, I forgot to tell you what that is. But you know what? Let's just explain it while I do it. So all you have to do is try and solve what x is equal to. Okay? So how are you going to do this? I'm going to rewrite it over here. 2 over 9 times 9 raised to the x power equals 18. This is kind of like first semester, super easy, right? In order for you to find out what x is equal to, all you gotta do is leave the x by itself. But the x cannot stand by itself now because what is it stuck to? Yeah, it's stuck to the 9, okay? So you know what? Our goal now is going to leave this whole thing by itself, which is 9 raised to the x power, okay? So then that means we gotta get rid of what? Yes, we gotta get rid of the 2 over 9. The relationship between the 2 over 9 and the 9 raised to the x power is multiplication, right? So the inverse of multiplication is division. Okay, so then in other words, what that means is you have to go 2 over 9 divided by 2 over 9. And this 2 over 9 is going to be in red because this is what we have to do in order to get rid of it. And that times 9 raised to the x power, because that's what we need to leave alone, is going to be 18. And then what did we just say we have to do in order to get rid of the 2 over 9? We have to divide by 2 over 9. But we know that division is the same thing as multiplying by its reciprocal, right? Okay, so then we're just going to have 2 over 9. And then instead of divided by 2 over 9, we're going to say times 9 over 2. Because that's what this is. Dividing by 2 over 9 is the same as multiplying by its reciprocal. You just flip it and get that. Right? And so I know that the only problem you're going to have over here is, oh, Miss Choi, how do you divide? Okay. So I'm just showing you because Mr. Berger has a good video, but he doesn't explain this step by step. So divided by 2 over 9 is the same as times 9 over 2. So then, now it's easy because 2 and 2 cancel out, 9 and 9 cancel out. So 1 times 1 is 1, 1 times 1 is 1, 1 over 1 is 1. So now we're just left with 9 raised to the power of x. And this is exactly what we wanted, right? But then let's go ahead and finish this side. Oh, how do you do this? Easy answer. 18 times 9 divided by 2. The way I like to do it is I make 18 over 1 because 18 is the same as 18 over 1, right? 18 divided by 1 is 18. And then we see if there's anything we could cancel out. So I talk about my dancey dance in first semester, but we have a dance move for this. Grab a number from the top, grab a number from the bottom, but we should be able to divide both by the same. Okay, so 2 and 18 can both be divided by 2. So this is a 1. This becomes a 9, right? Okay, so I've been writing too big. I have no space here, so I'm just going to have to write here. So anyway, on the left-hand side, I'm only left with 9 raised to the x power. On the right-hand side, this becomes a 1, this becomes a 9, right? So 9 times 9 is 81. From here, the interactive textbook has really good examples for you to work on, and 9 raised to the x power means 9 times how many times, right? So how many times do you have to multiply 9 to get x? Well, let's figure it out. 9 raised to the x power is equal to 81 is going to be 9 times 9, because 9 times 9 is 81, right? We have to make sure that the base is the same. In other words, that's 9 raised to the x power equals 9 multiplied 2 times. That's a small 2 on top. Okay, so since our bases are the same, 9 and 9 is the same, in order for us to make sure that these two equations are exactly the same, what else do you think should be the same? Yes, the x and the 2 should be the same, okay? So your answer is 2. And so then you'll be like, Miss Choi, I don't understand what they're talking about. What is the equality of bases property? Well, you can go back. I'll show you where you would see it. But what that basically means is, you see the 9? This is what we call a base. Okay? And so if the bases are the same, then we can safely say the exponents are the same, which is the blue ones that I highlighted. There are some limitations. The base, this number 9, cannot be negative. It cannot be 0. It cannot be 1. Well, why is that? That is a very good question. Let me just go ahead and type in my answer 2 to show you that that is correct. Of course it is. It says correct. And what we're going to do now is just go back. Let me put this back into regular size. I want you to go ahead and work on this practice by yourself. As you can see, I did all of them. Okay, because I wanted to make sure that there are no mistakes. I did find a mistake over here in the textbook, and I wanted to let you know where that is. It's right here. Like when you try and graph it, the 3,16, it won't graph correctly, but that's okay. Don't stress out over this part right here, okay? But everything else, make sure you do them, okay? It's actually really cool. But anyway, as far as the definition is concerned, there you go. Where is it? Where is it? The equality of bases. No, I feel like I'm wasting your time right now. Huh. Okay, I can't find it right now really fast, but I know that you can. Oh, there you go. Equality of bases property. So this is something that you obviously have to, know. So make sure you copy and take notes on them. Okay? All right. So now let's move on. In your interactive textbook, it kind of shows you how to solve a real world equation right here. Okay? And so it gives you a really interesting question right here. It says, a town has 55,783 residents, and the population is increasing at a rate of 5% per year. And the town council is offering a prize for the best prediction of how long it would take for the population to reach 75,000. And you have to make a prediction. Okay. So then you could be like, Miss Choi, I'm like completely dumbfounded because I don't even realize how you solved the other question. And now all of a sudden you're giving me a word problem. I say, yay. Okay. So anyhow, if you go down the list, the interactive textbook, ask you all these questions. And if you follow along, everything makes sense. Okay. So it's all about how hard you work. But anyhow, let's take a look at this right now. Let's go ahead and set this up. A town has 55,783 residents, so that's why it says analyze the information. What is the important information? Starting population is that, right? So I put that in, got it correct. And what was the ending population? Well, the population is increasing at a rate of 5% per year. That's important. The town council is offering a prize for the best prediction of how long it would take for the population to reach 75,000. Make a prediction. So the ending population is 75,000. What is the growth rate? Well, it says 5 here, but it's supposed to be 5%. Because 5% is different from 5. 5% is 0.05, okay? If you were to use regular numbers, not a percent. So you need this information, and once you have this information, what you can do is go ahead and set up an equation, okay? So this is what you're going to do, okay? I don't know if you remember this, but this is from module 14, right? Okay, so this is an exponential function, and of course that would be a fancy way of saying y. And then a was the beginning amount. Remember, this was how much money grandma started off with when, you passed Miss Choi's test with an A. Remember that? Okay, so that is the beginning amount, and what was that? That was how many times your grandma was going to multiply, right? That was the rate. And then the x represented what? How many times you passed Miss Choi's test with an A, right? And then what would this be? The answer, which is how much grandma's going to give you. So it's kind of like the same thing in this question. You could apply it, okay? So f of x is basically what? Oh, that's the population to reach 75,000. That's pretty much the answer, 75,000. And then what is A? It was the beginning amount that grandma started with. Kind of like the beginning number of residents in this town. 55,783. Oh, okay. And then the rate is how many times did grandma multiply that number, right? Over here it says it's increasing at a rate of 5%. So if it's increasing at a rate of 5%, we gotta kind of think about this, okay? Because that's the number that goes in here. And then raised to the x power. X power would be what? How long will it take for the population? So that pretty much means like how many years would it take, right? So we just have to figure out this number. We have the rate. The growth rate is 5%, but we gotta express it correctly, okay? So if I have, and to explain this, I'm gonna just give you a different example, right? We have 10 people, okay, in a classroom, and the students are going to be increasing at 5%. Okay, so let's say I'm going to multiply this by 0.05 because 5% is 0.05. So then if you multiply this, you'll find out that you get 0.5. Okay, so then if Miss Choi's classroom starts off with 10 students and then the growth rate is 5%, does that mean like after 1 year I'm only going to have 0.5 students? That doesn't even make sense. We already had 10 students, so if we're going to have more students, we should have more than 10 students, right? So then what do we have to do? Obviously, we cannot just put 0.05. That's not the number that's going to go in here. So then, what if I go 10 times 1? Then that's 10. That means no change. What if I go 1.05? Because no change is 1, but if you're going to increase, you're going to add the 5% to the 1. So what if I go 10 times 1.5? You know what happens then? Then I get 10.5. Now this is really silly because we cannot have 10.5 students in Miss Choi's classroom, but at least it makes sense that we started off with 10 students, and after 1 year, if the growth rate is 5%, 5% of students, that's the rate of increase for the number of students in Miss Choi's class, you know that it has to end up being a number bigger than 10, right? So I hope you can understand what I'm saying, but basically, I said all that long thing to explain to you that this has to be 1.05 because the growth rate is 5% and 5% is 0.05, but we can't just multiply that to the original number. This is an increase of 5%, so if there's no change, that's going to be 1. You have to multiply by 1, but then you're going up by 0.5, so you got to go 1 plus 0.05, and that's what you put over here. Once you understand how to set up the equation, solving it is so easy. You just have to use the Desmos calculator, but that's just going to take a long time for me to explain, okay? So, for you to solve this using a graphing calculator, you have to do two things. You have to separate this into two equations, okay? So you're going to say, for one equation, you're going to say y is equal to 75,000. And then for the other part of the equation, you're going to put this, which is y is equal to 55,783 times 1.05 raised to the x power. So then, how are you going to solve this if you don't have a graphing calculator? That's why I told you that you have to download the Desmos calculator. So let's go ahead and do that, okay? I'm gonna just go ahead and open up a new tab here. I'm going to go into my little Rubik's Cube, and then remember we all downloaded Desmos because you needed it for the test. Okay. So I'm just gonna click on that, and here's my equation. So remember the two graphs. Remember how we separated the equation into two graphs? Right here. Okay, there you go. Y is equal to 75,000 and all that. So what we're gonna do right now is just plug that in, okay? So here's my first equation. Y equals, I know I wrote down my number somewhere, 75,000. Then I'm going to write my second equation, which is y is equal to, and then 55,783 times, and then I put that in parentheses, 1.05, and then raised to the power of, you click on this, raised to the power of x. So then, what's going on? I don't see any graph, right? So there's nothing wrong. This is where you have to use your brain, okay? So first of all, you can just go ahead and scroll out to kind of get a peek at where the graph is. Oh, so there is a graph, but I can't figure out an answer like this, right? Okay, so you have to use your brain. Click on the wrench. That is a wrench, right? And then I want you to come up with, see where it says x-axis and y-axis? That basically means you're going to tell Desmos like what part of the x-axis and the y-axis you want to see. And so these are the range of numbers. You see, you start with negative 213.8. That means that's the starting point right here. See, as you can tell. And the x-axis goes as far as what? 213.7. You see that right there. Same thing, y-axis is starting from where? Negative 135.3. Okay, down here. That's where it is. And it goes all the way to what? 135.3. And that would be that point right here. So we can actually just adjust this ourselves so we can see the graph. Use common sense. Y is equal to 75,000. So the biggest number has to be obviously bigger than 75,000, right? So I'm just going to put 76,000. And then what do I see? A little red line over here. And so I'm guessing maybe I should see a little bit more on top. So instead of putting 76,000, I'm going to put 78,000. You know what? I'm just going to put 80,000. Okay? And then what should be my lowest number over here? Well, I'm looking at my graph and then, oh, I don't think I would have to go that low. But, you know, I'm just going to keep it over here because it's not like I'm looking for anything down there. I'm looking for the answer right here. But what about the x-axis? Do you really think that I have to go this far and that far? No. So you know what? I'm just going to change this to maybe negative 500. Oh, wait, no. Negative 300. And then I want to change this to maybe just say 100 and see where I go. Okay? Click on the screen. Oh, okay. It kind of looks okay, but for me to show you, it's not that great. So for the y-axis, I'm gonna see if I can go a little bit down, more down. I mean down further. So yes, I tried that. Okay, and then now I can zoom in and out a little bit. As you can see, I have an exponential function, and this is what you are used to seeing the whole time. And then what's this red line? Well, that is the first graph. Y is equal to 75,000 is basically a straight horizontal line. And then this is an exponential function, and that would be the blue graph. So why did we graph the two lines? Because we want to find out what the answer is. And you know, if you just click right here, it basically just gives you the answer. But sometimes you see how this is really close to this one. So you don't know the difference between the y-intercept and then the answer. So which is why we know that the x value, we have to make it, go closer. You see the x value? You started from what? Negative, I don't know, way lower than negative 300. And then we're viewing all the way to way more than 100, right? So why don't I just go ahead and change it so we start x at maybe negative 200 and we go as far as 100. So I'm just click on the wrench again. X, let's say negative 100. And then over here, 100. And let me see if that's a little bit better. I think it is, because now I can see that these two numbers are separate, right? So I want to see the difference. So you know what? Why don't I make it all the way up to 50? Maybe that would help me see my answer better. My x-axis all the way to 50. Okay, yeah, it does make a difference. I mean, the answer doesn't really change. I'm gonna click right here. Okay, and so all I wanted to do was make sure that you don't confuse this one as your answer, because that's not your answer. This point is just basically the y-intercept for this red line. And our answer is supposed to be the point where the blue and the red lines meet. So 6.07 is the x value and 75,000 is the y value. What that means is when x is 6.07, y is 75,000. Okay, so in 6.07 years, okay, population is going to be 75,000. Let's go back. Okay, where's my question? We went back and my answer was 6.07. So how long will it take? Well, it's going to take 6.07 years. And so let's see if we can actually plug in the answer. 6.07, blah, blah, blah. Where's the answer? Okay.
Mommy, I'm going to take a bathtub.
6.07. Okay, so there you go. It says the population will reach 75,000 in about 6 years. And that's okay, because 6.07 was our answer, and it's kind of similar, right? Okay, and so that's it. This is a very complicated question for a lot of students, and so if you're scared, I totally understand. But, trust me, it's not that difficult. At least you can go ahead and brag to your other friends who are in higher level math classes that you're smarter than them. So let's try and solve just one question, and then we're going to be done for the day. The most important thing is this section right here. Of course, the other part too. You got to know how to solve those. But you also really have to know how to do these, okay? So I'm going to get closer. Make it bigger for you. Then we're going to scroll down. Okay, so let's set up the equation first. How many wolves do we have to begin with? We got 225. And the population is increasing at a rate of 14%. We know that 14% is 0.14. So if it's increasing, we got to add 1 to that. Okay, so starting with 225, and then it's going to be 1.14. Raised to the power of x, because we don't know how long it would take for the population to reach how many? Well, our answer happens to be 505, okay? So then, it says if necessary, round your answer to the nearest tenth. That means a number, and then with the decimal, only one number after the decimal, okay? So again, how do we plug this into our calculator? Separate it into two equations. Y equals 505. And then my second equation is going to be y equals 225 times 1.14 raised to the x power. And now I'm going to go into my Desmos calculator, aren't I? So let's do this. I already have my Desmos calculator open. So I'm just going to go in there. And I'm going to go ahead and get rid of both. And really cool thing is you see the setting that I have already created. It's still there, okay? So I can, if I don't like it and I just want to go back to how it used to be, where are they? There's a way to do that, but maybe it's default. Yes, if you click on default, it would just go back to how it used to be. Okay, anyhow, let's go ahead and put in the equation. Y equals 505, and then y equals 225 times 1.14 raised to the power of x. Okay, so obviously if you don't see the graph, you already know. Let's use common sense. Click on the wrench from the beginning, and then let's look. Y, the highest value is 505, so my y-axis, I'm going to just put 600. Because, oh, now all of a sudden the graph pops up. Maybe I don't have to do anything else. For the x value, let's just take a look. You know what? I'm not going to do anything because I already see obviously the answer. If I click on it right here, the answer is what? 6.17. Your x value is 6.17. When x is 6.17, your y value is 505. But they said to the nearest tenth, so I have to drop the 7. And when I drop the 7, 7 is equal to or greater than 5, so then I have to add 1 to 1. So my answer is going to be 6.2, right? So let's go back. I'm going to put 6.2. The wolf population will reach 505 in approximately 6.2 years. So I checked my answer and that is correct. You see how easy this is? Most of the time, my students do not have a difficult time coming up with the equation because that's so easy. They have a difficult time, not with graphing because graphing is so easy too, but they have a difficult time finding the graph after they graph it. And this is where we have to use common sense. A lot of my students are smart in math, but they don't have common sense. No, I'm kidding. So just remember, you have to use common sense. Your y value is 505, so find something, click on the wrench, and make sure that your viewing window is greater than 505, right? And then just look at the graph, and if it's difficult to find your x value, then we just have to go ahead and adjust the x values as well. So that's it for today. Obviously, when you come to class, you're going to be working on the evaluate section, and you wouldn't be able to access these questions. So obviously, I'm going to go ahead and give you access to the other parts, right? So there you go. If you click on resources right here and click on student edition, your printed version will show up. So I am not providing print versions anymore. You can just look at everything online, okay? I want you to use the interactive version. And then, of course, when you come to class, I want you to try and solve the questions over here in the evaluate section because you know your test questions come from here, right? So maybe pick one question from here and then pick one of the word problems. And then if you know for sure that you can solve them all, you're good for the day. All right, so happy learning.